All right. I hope you had a nice break. I was going over, wait, they can't hear me. I was going over the calendars. We have a very busy run from here until May the 2nd. It's basically every day. I know some of you, I was actually talking this over last night when I made up the rest of the year's calendar, and I know some of you have choir competitions and drama competitions and band competitions and things like that. We are not taking a single day off. So understand that if you are scheduled to be out, Avery, if you are scheduled to be out, you are responsible for the work. I know your directors tell you that, but I'm telling you, I will be requesting in advance, okay? Because we are not slowing down, we are not pausing, it is a dead sprint to May the 2nd, which is when your algebra EOC is. 100% committed, that's the goal. We get 3 days of review for the entire year. We have 3 days of review for the algebra EOC. In fact, I'm cutting unit 10 in half. So basically what we're doing is we're doing content of unit 10, but we're not doing the extension day, the review day, or the test day, because I can't. So we're literally picking up those 3 days, moving into after start. So we're going to finish content in unit 10, and then we have 3 days of review for the EOC, which is the entire year. And then we take a break on the weekend, we come back on a Monday. Monday is not review, Monday is like just me talking to you about strategies and things to think about and that kind of stuff. Then Tuesday you take a test. Okay? It's a 4-hour big thing. Okay? The 8th graders, in 3 weeks, the other 8th graders are taking their math star. Y'all will not obviously be taking your math star. During that day, y'all will be taking a mock star. Okay? We're going to give y'all a star algebra EOC test. It's obviously not the real one, but it'll kind of get you prepared. Those of you who are in 7th grade, you'll be doing the same thing, but I can't dedicate a day to do it. So y'all will be doing it over a weekend. It's a 54 question. It's just like a STAR test. It's the whole year. Okay? But what that'll do is it's kind of cool because that will give us an opportunity to see what we need help with. It'll even identify like, okay, so units 3 questions in unit 4, 2 questions in unit 6, and 1 question in unit 8. So you'll know then kind of how to study for the STAR. Okay? So more about that as we get closer, but that comes up in about 3 weeks. Any questions on all that garbage? When last we left you, we were multiplying polynomials. We learned 3 ways to multiply polynomials. Someone give me 1 way we learned to multiply polynomials, Ethan? FOIL, my favorite way. What's another way? Yes, sir. Box method. My least favorite way, but one that most kids like because it's easy. Yes. And double distributed. Perfect. Those are your 3 ways. I don't care how you do it. As long as you get the right answer, just make sure you're very, very careful. It says find the area. How do we find area of a rectangle? Length times width. Base times height. Which means length times width. So basically, x plus 4 times 2x minus 5 will give us the area. Now, let's see. Who did box? Raise your hand. Who did double distributive? Raise your hand. Who did FOIL? Okay, let's go for it. Okay, FOIL. First, outside, inside, last. X times 2x is 2x squared. X times negative 5 is minus 5x plus 8x. And then the last 2 is minus 20. If we did it properly, we end up with like terms in the middle. So the area of the first rectangle is 2x squared plus 3x minus 20. That is the area of the first one. If you missed it, it's all right as long as you understand how. Questions? Okay, on the second one, how do you find the area of the triangle? Yes, sir. Length times width or base times height divided by 2. So really we have 2 things we're going to have to think about, right? We've got to do the base times height part, which is base times height. So let's do that first. Let's do 4x minus 3 times 3x minus 2. And this time, let's do a different method. Let's do double distributive, right? That's where we take the first one, 4x, multiply it times 3x minus 2, And then take the second one, minus 3, and do 3x minus 2. And now we just go through our distribution process. So we end up with 12x squared minus 8x minus 9x plus 6. Like terms in the middle, so 12x squared minus 17x plus 6. Guaranteed, that is answer choice A. Because why? We haven't divided by 2. When you divide by 2, you divide everything individually by 2. You divide this by 2, you divide this by 2, you divide this by 2, and what you end up with is 6x squared minus 8 and 1/2 x plus 3. Now, could you write minus 8.5x? Absolutely. Can you write minus 17/2 x? Absolutely. As long as you understand it's divided by 2 for every single term. Any questions on that? They love the triangle questions. They love the triangle questions, right? Or they give you the side length of a square and say find the area. So it's something squared, which is the something times the something. Remember, guys, don't do shortcuts on this stuff. It'll bite you in behind. It really will. Okay? Any questions on all this? All right. Let's jump into what we're doing today. Today we're doing multi-step. Multi-step multiplication. Look at this first one. How many different things are happening? There's a lot going on, right, Avery? What's basically happening in this expression? Yep. Yep, so you have this. Wait, what? Okay, yeah, and then you have addition in the middle. You have to be very careful about what you're going to do. Because really, when you see this, what I want you to think of that as is 3x minus 1 times 3x minus 1. Don't do shortcuts. It will mess you up. So what we end up with is in this first one, we distribute, we end up with 3x squared minus 12x. We distributed the 3x to both of those guys. Then we have addition. And we're adding the entire second part. Now, in order to do the second part, let's go ahead and just spoil this. First, what's 3x times 3x? 9x squared minus 3x minus 3x, negative 1 times plus 1. So it's 9x squared minus 6x plus 1. That is what we're adding right here. This becomes 9x squared minus 6x plus 1. Now you'll notice I put it in parentheses. Does it matter? Would it matter if it was subtraction? That's why I suggest you put it in parentheses. Guys, if this was a subtraction sign, it would very much matter. It would very much matter. It doesn't because it's addition. So basically what we can really do is just do 3x squared minus 12x plus 9x squared minus 6x plus 1 and start dealing with like terms. I have an x squared guy there and an x squared guy there. 12x squared. Remember, don't change your exponents when you're adding. Then I have this x guy and this x guy. There's our negative 18x. Then we have this little dude sitting off to the end. And that's my answer. That's my sum. That's it. This is where making sure that you're organized and you know the rules of exponent multiplication are critically important. Muy importante. Okay? Any questions on this? Jessica drew a floor plan for her kitchen. The length of the kitchen is 5 more than 3 times the number x. The width is twice the number x increased by 1. I strongly encourage you to do 2 things. Number 1, draw a picture. In this case, we're going to assume that the kitchen is a rectangle. Usually it will tell you. And then remember what we wrote above? I would do that. The length of a kitchen is an equal sign. 5 more than 3 times a number x. So what does that mean the length is algebraically? 3x plus 5. The length is 3x plus 5. That is the length. The width, W, is twice a number x increased by 1. Do we flip on that one? Andrew, write all this down, right? Do we flip on that one? Does anyone see a from or a than? I do not, therefore my width is 2x plus 1. Write an expression that represents the area of the kitchen floor in square units. What's my expression? Yeah, area equals, although that's an equation. Once you put an equal sign, it's an equation. 3x plus 5 times 2x plus 1. By the way, that is your answer, because it didn't say to solve it. It didn't say to find the area. It said to write an expression. Okay? Now, could we solve that? Yes. Any questions on that? That's exactly the kind of question you'll get on a test. Okay? STAR test and otherwise. How do we find the area of a shaded region when you get a problem like this? Joey? Perfect. You have to find the area of the big guy and the area of the small guy, and then you subtract them. So let's do the big one first. 3x minus 5 times 2x, 3x minus 5 times 2x plus 1. Now I'm going to go ahead and solve these using FOIL, but again, you may solve them however you wish. Okay? So FOIL this. Remember the mess up on 3x times 2x. 3x times 2x is 6x squared plus 3x minus 10x minus 5, which means 6x squared minus 7x minus 5. This is the area of the larger rectangle. The smaller rectangle is right here, so it is x minus 1 times x plus 3. So exactly the same process. We FOIL it. X squared plus 3x minus 1x minus 3, like terms, is x squared plus 2x minus 3. This is the area of the smaller rectangle. I want to pause right there, make sure everyone knows how I found the areas of the big rectangle and the area of the small rectangle. And Joey said we're going to do what now? We're going to subtract. It's the large one, 6x squared minus 7x minus 5, minus x squared plus 2x minus 3. Now you'll notice I put the second one in parentheses again. Does it matter this time? Absolutely it does, because we have to distribute this subtraction sign to all your terms and then rewrite it. So what we end up with is 6x squared minus 7x minus 5 minus x squared minus 2x plus 3. And I'm not sure how I got those terms with those signs. You're essentially distributing -1, right? And now we have like terms. We start with our x squared guys. What's 6x squared minus x squared? 5x squared. Then we start with our x terms. We have minus 7x minus 2x, minus 9x. And then we have minus 5 plus 3 is minus 2. Bless you. This is the area of the shaded region. Any questions on that? See if you can figure that one out. But you're going to find x minus 5 cubed, please. X minus 5 cubed. using whatever method you wish to use. First thing I would do is I would do x minus 5 squared. When I do that and I FOIL it, I end up with x squared so I end up with x squared minus 10x plus 25. And I still have to do what? What's left to do, guys? I have to do it, yeah, I have to do it times x minus 5 again. So it's this times x minus 5. Now I will tell you, when I've got a 3 times a 2, I usually go to box. I will usually, when I get something like this, go to the box method, only because it ends up being a little bit easier for me to organize. So I end up with x squared minus 10x plus 25 times x minus 5. And then I just go along and I fill in all the insides. This is x to the third. This is minus 10x squared. This is plus 25x. Remember, I'm multiplying the corners. So I'm multiplying this times this, so minus 5x squared plus 50x minus 125. And all that's left to do is to bring everything together. And remember, my diagonals should have my like terms. So I end up with x to the third minus 15x squared plus 75x minus 125, and that is the value of x minus 5 to the third power. Don't try to do something cubed all at the same time. It can be done, but it's kind of messy. Okay? I don't even do that. I got mad crazy math. Okay? Just take your time, go one step at a time. Any questions on this? All right, here's what you got. You got classwork and homework tonight. I'll put the answer keys out, get on your classwork, and then pick up your homework once you are checked and ready to push forward. Okay? Gonna wait back up. It's time to get going again.